Hello everyone, and welcome to this video. In this video, we'll be considering the following topic: 5 levels of organization in organismal complexity. Let's begin. So let's first talk about the first level, which is going to be the protoplasmic level. At this level, what happens? Well, first of all, it's important to know that this level is the simplest level. It's the simplest level characteristic of unicellular or acellular organisms such as protozoans, amoeba, and paramecium. So when you think about the protoplasmic level, think about unicellular organisms. Uni meaning one cell, as compared to or in contrast to multicellular cells, right? Multicellular means many. Unicellular means one. So at this level, think about your unicellular organisms, your amoeba, your paramecium, your protozoans, right? Now, what is happening inside our protoplasmic level? Well, the entire body consists of a single mass of protoplasm, a living substance, enclosed by a membrane. What else do we know about protoplasmic level? Well, all functions, what function are we talking about? Locomotion. Locomotion means movement. Nutrition, respiration, excretion. Excretion refers to the getting rid of waste, right? Reproduction refers to making copies of oneself. Response to stimuli, that's sensitivity. All of these are performed within the boundaries of the single cell by its organelles and protoplasmic components. So at this level, all of its vital processes of life, such as movement, nutrition, respiration, all these things happen within the protoplasm, within the boundary of the single cell, I should say, and its organelles and protoplasmic components. What else do we know about this level? There's no division into tissues or higher structures, and complexity is limited to subcellular specialization. That is the protoplasmic level. Remember, for protoplasmic level, this is going to be a simplest level. And when you think about protoplasmic level, think about your unicellular organisms, your protozoans. Now let's move on to the cellular level. So the cellular level, this level is seen in simple multicellular organisms. So now we're entering into the world of multicellular organisms, but we're still talking about the simple multicellular organisms. So protoplasmic level, we're only focusing on unicellular organisms, your protozoans, such as your amoeba and your paramecium. But when we venture into the cellular level, we're talking about simple, but multicellular organisms, where the body is composed of an aggregation of cells that are not yet organized into true tissues, for example, sponges and peripheral. So a good example of this would definitely be your sponges. So when you think about cellular level, think about your sponges. Cells may be loosely associated but perform similar or independent functions, but they do not form into differentiated layers or tissues with specialized roles. So here we do not yet have true tissues, right? What else do we know about our cellular level? Each cell largely retains its individual capabilities, though some division of labor may begin to emerge. And finally, this represents an advance over the protoplasmic level by having multiple cells cooperating. So that's the advancement. That's the difference between the protoplasmic level and the cellular level. With the cellular level, we have multiple cells cooperating, right? But with the protoplasmic level, we're just thinking about unicellular organisms, acellular organisms. They operate by themselves, and these single cells are gonna be able to perform all the functions of life, like we talk about locomotion, nutrition, respiration, all that stuff. That's the protoplasmic level. So when you think about protoplasmic level, think about one cell performing all the functions. When you think about cellular level, we start to merge into our multicellular organization area, but it's still simple. We don't have no true tissues being formed as yet. All right. Now let's look at our next level, which is going to be the cell tissue level. So here, similar cells aggregate into definite patterns or layers to form tissues. So this is where we have the formation of tissues, to form tissues that perform common functions. For example, in our coelenterate, like hydra or jellyfish. So here in our cell tissue level, this is our first site of true tissues. This is where we're going to see our true tissues emerge. We didn't see that in the protoplasmic level. We didn't see that in the cellular level. We see it in the cell tissue level. The organism shows the beginning of true tissue differentiation, where groups of cells specialize for protection, digestion, or support. Cell tissue. This marks a key increase in complexity as tissues allow division of labor beyond individual cells, but organs are not yet present. So let's go on and march along. We have first the protoplasmic level. Think unicellular organisms. Think one cell performing all activities. Then we have the cellular level. Think sponges. Think multicellular organisms, but still think simple, no true tissues. Then we move on to the cell tissue level. This is where we have our first true tissues being formed, right? But we do not have the formation of organs yet. That is going to happen in our next level, which is the tissue organ level. At this stage, different tissues combine to form distinct organs. Because remember, cells group together to form tissues, and then tissues group together to form organs. So at this stage, different tissues combine to form distinct organs, each specialized for a particular function. For example, in flatworm, like planaria. An organ is a structural unit made up of two or more different tissue types working together. For example, a simple digestive organ. Now, in our tissue organ level, this level introduces localized complexity where organs carry out specific tasks more efficiently than dispersed tissues alone. And this is very good because, like we said, cells group together to form tissues, then tissues group together to form organs. So this is different from anything we saw before because we never saw organs yet. Right? In our protoplasmic level, we didn't see any organs yet. That's just one cell. It's impossible to see any organs yet. In our cellular level, we didn't see any organs yet. How could we see any organs? We didn't even see any true tissues there in our cellular level. In our cell tissue level, we'll have first sight of our true tissues. But we didn't have a group of different tissues working together, right? To grouping together, coming together to have a specific function like how we have it in our tissue organ level, where we have our first sight of our true organs. So that's going to be in our tissue organ level. But that's not it. That's not yet. That's not the highest. The highest one that we have is going to be organ system level. This is the highest level of complexity described here. This is the highest level of complexity described here, found in most higher animals. For example, annelids, arthropods, chordates, including humans. So humans are going to have this organ system level. Different organs coordinate and work together to form systems, like your digestive system, your nervous system, your circulatory system, your skeletal system. So now we have our formation of systems, and systems are formed by groups of organisms working together to perform a specific function. Okay, organ system level. Each system performs a major physiological function through integrated organ activity. So they're working together, right? This allows for high specialization, interdependence, and overall organismal efficiency. All right, so that is our highest level. So let's go ahead and talk about it. Let's look at this diagram, which summarizes our information. So we know that we have this atom, and after the atom, we have the molecule, then we have macromolecule, and then we have the organelle. Then inside of our cell, we know that the cell consists of different organelles that work together to help the cell to function. Then we have groups of cells. What happens when you have groups of cells? Groups of cells come together to form our tissues. So tissue consists of groups of cells working together to perform a specific function. Then, in order for us to, after we finish get our tissue, in order for us to get our organ, we need groups of tissues come together to perform a specific function, and that's going to be our organ. And then in order for us to get our system, we need groups of organs working together to perform a specific function, and that's going to be your organ system. And then groups of systems coming together is going to form an organism, and an organism is going to be consistent of all these different parts. Okay, so hopefully you have a better understanding of the different levels that we have. We have the protoplasmic level as the simplest level. We have the cellular level. Then we have the cell tissue level. Then we have the tissue organ level. Then we have the organ system level. Okay, so hopefully that helps you to understand these things better. And hopefully this diagram is good at helping to summarize everything for you. And that brings us to the end of this video. Thank you so much for watching, and I'll see you in the next video. Take care, everyone. See you soon.